This is our lesson number 31 and the part number 2 regarding spinel. We are learning the beauty of the spinel here. In this cover photo, here I mentioned the color of cobalt spinel. I know a lot of people, they have no idea and about the color of the cobalt spinel. This is electric blue color. Remember this color. And these are the inclusions we are discussing inside. This is spinel inclusion inside the spinel. This also spinel octahedral inclusion. See, 8 sides, 8 triangular sides are there. See, 8 triangular sides. Spinel inclusion inside the spinel. This also spinel inclusion inside the screw, inside the spinel. If you forget to subscribe, please subscribe and give the knowledge to the friend or your relative to get the idea and join to the gem industry after learning. This is my free gift for the youth. In this video, we are learning about spinel. In part 1, spinel spectrum is here. In part 1, we learn because of iron, due to iron, chromium and cobalt content, it gives the color to the spinel. Can you remember? I mention it again because it is important. Iron, chromium and cobalt give the colors. This is cobalt spinel. I said earlier, electric blue color. This is the color should be there. If there is no this color, it should not be the cobalt spinel. But RI checks from the laboratories and they tell cobalt, but you can't sell it. To give the price, good price, we need the color like this. It is cobalt spinel. Now look at this difference. The left side, these all stones are natural spinels. Here it is separated 6 stones here. It is synthetic, flux synthetic. Be careful when you are buying rough or cut and polish spinels. There are a lot of flux synthetic spinels in the market. Now look at this shape. There are triangular, four sides are there. In the top side, there are 4 and the bottom side also 4, altogether 8. See, top side 4 and the bottom 4, 8. So this shape is called octahedral. Octahedral. There are 8 sides. One side is, one plane is triangular shape. 8 sides. That is the crystal shape of the crystal spinel. So remember that in the synthetic spinels also, they are creating with the 8 sides like this. See, same. Be careful. You have to get the lab certificate to get the difference between natural and the synthetic, like amethyst. Natural and flux synthetic red spinels here. 6 samples on the right on display. These are the synthetic spinels. Flux means the method they have done this. Be aware that these synthetic spinels are growing as octahedra, very similar to natural spinels. Only careful observation and sophisticated analysis will tell the difference. If not, can't. You have to forward the stone to the well-equipped gemological lab. If not, they can't tell. So be careful. There are a lot of synthetic spinels in the market. Natural with the natural crystal shape or after cut and polished. So be careful. Now I need to explain here. There are two images. Look at this one. These are the apatite inclusions. Apatite is another mineral. Inside the spinel, there are apatite inclusions. And they are star-like outgrowths. These growths are like stars, star growth. Along the 60-degree hexagonal plane, you can find the 60 degrees hexagonal plane also in these stars. It is very special inclusion inside the spinel. Looking much like stellate dislocation systems in the cobalt blue spinel. It is star there, but it is dissolved light, dissolved starlight. This is the famous inclusion inside the cobalt spinel, cobalt blue spinel. And look at here, this inclusion, look at here. You know the planet Saturn. Planet Saturn is very famous with their rings. So look at this inclusion. It is Saturn-like, Saturn ring-like inclusion is there in this red spinel. This is from Burma. In this Burma spinel, octahedral, that means 8 sides spinel inclusion is here. 8 sides, you can see the 8 sides with the Saturn-like, Saturn ring is there. So it is very special. Saturn ring octahedral spinel inclusion is very common inside the red spinel. This is from Burma spinel. And here, euhedral inclusions and octahedral inclusions in the Burma red spinel. Both are red spinel. Euhedral means, what is the difference between euhedral and octahedral? Octahedral means 8 sides. 8 sides. Euhedral means, euhedral mineral shows perfect or nearly perfect crystal faces. Nearly perfect or perfect crystal faces are there. So, all are spinel inclusions inside the spinel, euhedral. Octahedral inclusions in the Burma red spinel. See, you can remember remember that part 1, we discussed the spinel shape, octahedral. Now look at here. Spinel inclusion is in the spinel. See the 8 sides. Can you identify 8 sides? Top and the bottom. So it is octahedral spinel inclusion. Inside the spinel, there is an inclusion made out of spinelos. Look at here. Octahedral crystal with stress fractures, which give such inclusions the flying pyramid. It is like a flying pyramid. See, flying pyramid-like inclusions are common in spinels, natural spinels. So you can identify where there are synthetics also. It is different. Now we are moving to important part. How we check the spectrometer. What is spectrometer? I added here spectrometer. This is eyepiece. We need to see from here. This is a prism. Here, light source comes here. Light comes from here. Then light rays go through the prism and convert it to this location. Then we can see the spectrum. White color is derived to 7 colors. No, we can see the spectrum from here. This is called spectrometer. How we see this? We can see like this. When we look at this eyepiece, we can see the colors like this. 400 nanometers up to 700 nanometers. 400 to 700 nanometers range is the visible light range, visible wavelength. So, this is the slit. Slit means here, we can control the coming light ray by adjusting this slit. If we need smaller amount of light, we can adjust this. like that. Align spectroscope to maximum light entering through the slit. Then when you see, you can see the nanometers. NM means nanometers. 400 to 700 is calibrated there. We can see the lines. Where are the lines? So that black lines tell us the stone is, what kind of a stone is that? So this is called spectrometer. How it works? Look at this diagram. Source light comes to this mirror and it reflects the light to the prism or grating. Here, this is the grating or prism. Then prism breaks it into 7 colors and send it to this mirror. That mirror is sending this, all the colors, spectrum. Then the stone absorbs something and give the detector, tell us what nanometers are the absorbed light. So we can identify the light, identify the stone. This is called electromagnetic spectrum. In this electromagnetic spectrum, visible area is this. We can see this visible area 400 nanometers to 700 through the spectroscope. So this top area and the bottom area invisible and very dangerous for the human cells. So invisible part is filtered by the ozone layer in our earth. You know it. I think if you remember the science, you can remind it. How this happens? This is gemstone. White light comes with 7 colors. White light includes 7 colors. It comes through the stone and stone is absorbing some kind of colors. Some amount of nanometers it is absorbing. So after absorbing, it reflects only red. Then we can see this stone as red stone. So absorption part is black because no color there. So this is the concept we are checking through the spectrometer. There are a lot of lessons you can meet again and again and understand little by little advanced. What is this? This also spectrometer. This is flexible light, fiber optic light. This is the gem. Handheld, or you can use this stand to hold the spectrometer. This is handheld spectrometer. It is little bit less price. This is another fiber optic line and the spray is here. This is the place we are placing gemstone, and eyepiece we can see the absorption spectra. Which color range is absorbed by the gemstone? If we see through the incandescent bulb, this is the spectrum we can see through the spectrometer. If it is white light, we can see it is like this, white fluorescent light. If it is yellow fluorescent, it is like this. If it is sunlight, this is the red, green, blue area. So we can use sunlight also or another light. Right. Now, look at the absorption spectra. For example, here, absorption lines from natural red spinel is here. There are 3 lines. If it is synthetic red spinel, it is different. See these 2 differences. Natural red spinel have 3 absorption lines here. Which part? Red part. And synthetic red spinel, only 1. And here black area, absorption area. It is wider than the synthetic. So this is the test we have to do to identify the natural and synthetic red spinel. We can't check with the RI. So this is very important. Now look at the diamond. If it is diamond, absorption spectra comes like this. 700 to 400. This is the place. 450 nanometers, and here. There are two lines. Then here black area. Black area. Another diamond gives this. Ruby. In green area, there are two lines, and the red area also two lines. It is ruby. Spinel. In red area, see three lines. No any other lines. Emerald, you can see three lines. See the difference between spinel and emerald. Garnet, see the absorption spectra here, 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 here. See the width is different. So it is garnet. So garnet and spinel can change, identify superbly. Zircon, see the absorption spectra in red color area 3, 2, 4, 5, 6, 7, and the yellow area also 1, green area also there, blue area also 1. It is zircon. Look at the apatite. These are the absorption areas, lines. Another spinel one here. Then black area, 3 black lines. Here, 2. See, this is the difference here, mentioned here. So this is very important part. Look at the peridot. Peridot, there are 3 lines in the blue area. This is the spectrum you can see through the spectroscope. In the blue area, there are three lines here. Peridot may be difficult to see based on your light source. Generally, use a lesser intensity of light. Remember, you need lesser intensity of light. If the light is powerful, you can't find these black lines. And use your peripheral vision to look in the direction of the iron lines as shown. Peripheral vision, I mentioned in 47 or 57, lesson number. I forgot the number. In future lesson, I explain it very well. You can follow up that also later. And look at the ruby, sapphire, emerald, almandine garnet, peridot, zircon, red synthetic spinel, red selenium, red paste, it is synthetic, cobalt, here, blue paste, cobalt, red paste, cobalt, both all are synthetics. Now you can understand how to identify with the spectroscope. Remember, you need generally use a lesser intensity of light to see these lines. If your light source is more intense, you can't identify these black lines. Right. If you forgot to subscribe yet, please subscribe, like, share, and give a comment. Now these are the some tests you can do and identify gems. You need this jadeite filter. It is called Chelsea filter. And the 10x loop, 10x triplet loop. This is diachroscope. You can see the double refractive or single refractive gem with the diachroscope. You can learn more in another lessons. Join us, learn and enrich your future. We will meet with Spinel part 3 in the next lesson, lesson 32. Please subscribe, press the bell icon and give like and share. We will meet on lesson number 32 next day.